Hello guys, uh, welcome to the session on preparation for the persistent placement drive. Hello guys, uh, welcome to the session on. So in this session we will discuss on data structure concepts, data structure concepts, and questions, questions on the data structure concepts. So that mainly we'll select the gate questions, the previous year gate questions on data structure. Okay, so data structure, what is data structure? Data structure is a group of data elements, is a group of data elements that are grouped together under the one name, group of the data elements. So that is data structure. So these data elements are called the members. The data elements in a group, these are called members, and they can have the different types and different length. The members or the data elements in the group, they are having the different types and different length. Some of them store the data of same type while the others store different types of data. Okay, the group, it may be the same type of data or the different types of data. So the data structures are used to store the data in a computer in an organized fashion. Data structure are used to store the data in a organized fashion. So that is data structure. So what is the ADT, abstract data type? Abstract data type. So the ADT stands for the abstract data type, and it is a mathematical model of the data structure. Mathematical model of data structure. The abstract data structure that describes a container which holds the finite number of objects. Okay, finite number of the objects, where the objects may be associated through a given binary relationship. So abstract data type, that means it describes a container that holds the finite number of objects, finite number of objects that are associated through a given binary relationship. It is a logical description of how we view the data and the operations that are allowed without regard to how they will be implemented. It's a logical description. Okay, so the abstract data types, it gives the logical description, the description of how the data will be viewed and operations that are allowed. It is considered only with the data is representing and how it will eventually be constructed, how or what the data is the representing and how it will be eventually constructed. So it is a set of objects, operations. For example, the operations like the list, insert, delete, search, sort. So these are the different operations. So abstract data type means it is a mathematical model data structure, and it holds the finite number of objects, and that may be associated with a given binary relationship. So it is concerned with the what the data is representing and how eventually it be constructed. The abstract data types, there are following are the basic some of the abstract data type of data structure: stack, queue, and linked list. Stack, queue, and linked list, these are the some of the basic abstract data types: stack, queue, and linked list. So stack, it's a list where the insert and remove takes place only at the top. Okay, the insertion and the remove of item that is take place, that is only at the top. It performs the last in first out operation, LIFO, last in first out operation. So that is the stack. So here the data that will insert and remove, that takes place only at the top. The operations of the stacks are to insert the element at the top of the stack, remove the element from the top of the stack, and it return the element at the top of the stack. So push, pop, and top, these are the operation of the stack. It removes, insert and remove the element that takes place at the top. So that is the operation of the stack operation. Okay, so here the insertion at the one end, and also the removing of the element is also at the one end. So it's a last in first out operation. What is stack is a the last in first out operation. Okay, then comes to the queue operation. So queue, it is a list where the insert that takes place insert takes place at the back, but remove takes place from the front. Means it is a queue that insert takes place at the back, insertion that takes place at the back, means insertion at the one end and deletion from the other end. So a list where the takes place insert takes place at the back, but remove takes place at the front. So it performs the first in first out operation, first in first out operation, that is queue. Last in first out, that is stack operation. So the operation of the queue, the insert the element at the back of the queue, inserting the element at the back of the queue, back of the queue, inserting the element at the back of the queue, and remove the element. So this insertion, that is called as the NQ operation, inserting the element at the back of the queue. So that is called as NQ operation, and remove or the return element from the front of the queue. So that is called as DQ. So in this queue, insertion is the insertion of any element at the one end and removal from the another end. So that is queue operation. Then linked list. So these are all abstract data types. The different types, abstract data types: stack, queue, linked list. So linked list is a linear collection of data element called linear collection of data elements called nodes, pointing to the next node by means of the computer. So linked list is a linear collection of the data elements, that is called as the nodes, and pointing to the next node by means of a pointer. Here this particular node, it is pointing to the next node. So data address. So it is a linear collection of data elements, linear collection of the data elements. So that is called as the nodes pointing to the next node. This particular node, it is pointing to the next node by means of a pointer. Each node that consists of its own data, each node that consists of its own data, address of the next node, and forms the chain. So each node, so this is very important in linked list, each node that consists of its own data, it consists of its own data and the address of the next node and forms a chain. So linked list is the linear collection of the data element, that is called as the node, that is pointing to the next node. The nodes are pointing to the next node by means of a pointer, and each node that consists of its own data, and also it addresses to the next node that forms a chain. So this is the linked list that contains the data and its own data, and also it contains the address of the next node. So that is the linked list operation, data and the address of the next node. Okay, so the advantage of this abstract data type is it is reusable. It is reusable and ensures the robust data structure. It it is a reusable and ensures the robust data structure, and it can be reused at several places. It can be used at several places. It is reusable and ensure the robust data structure. It can be reused at several places. It reduces the coding effort. It reduces the coding effort, and encapsulation ensures that the data cannot be corrupted. It reduces the coding effort and encapsulation that ensures that the data cannot be corrupted. And it is based on the principle of object-oriented programming and software engineering. It is based on the principles of the object-oriented programming and the software engineering. So let us discuss what are the different applications of the stack operation. What are the different applications of the stacks, where we can use the stacks? Some of the applications of the stacks are follows. So here the function calls, reversal of a string, function calls, reversal of a string, checking the validity of an expression that contained the nested parenthesis, checking the validity of an expression. Okay, so the validity of an expression that contained the nested parenthesis, and conversion of an expression, conversion from infix to postfix, infix to prefix, postfix to infix, prefix to infix. So the conversion of expression, these are all applications of the stack. Function calls, reversal of a string, checking the validity of the expression that contain the nested parentheses, then conversion of the expressions from infix to postfix, infix to prefix, postfix to infix. Okay, evolution of the expression. So the representation of the expressions. So how we represent, for example, the infix. So in this infix, we represent the infix with the operator in the middle between the operands a plus b, infix. So here also a plus b into c. The operands are placed between the operator is placed between the operands. Okay, a plus b into c, then a plus b into c minus d. Okay, so that is infix expression. And the prefix means the operator will be at the first will be operator, then after that operands. So for this corresponding this expression a plus b, okay, a plus b. So what is the prefix of expression? Prefix means the operator will come first, then a, b. So that is prefix operation. Then postfix, the operator will be after the operands. Okay, so that is ab plus. So in this way here, and also with the associative, also with the associativity and their precedence. Okay, so a plus b, this infix expression, the corresponding prefix is a plus b into c, right? So here this is the first preference, So the prefix for this is plus a. So here star will come. Okay, star into BC. So likewise postfix expression. Okay, postfix expression. So these are all representation of the expressions. Then next comes the describe the stack operation. Stack operation. The stack operations are, there is a leap, last in first out, last in first out. So the operations are push, pop, push the elements in the stack. The location is specified by the pointer. Push means push the element into the stack, and pop means that removes the element out of the stack. So in this stack, insertion and deletion at the one end. Okay, in in this particular stack, insertion deletions are from the one end, right? That is last in first out operation. So push, pop, then swap the two topmost elements of the stack can be swapped. The two topmost element that can be swapped. Here one, suppose the data 1, 2, 3, 4. Okay, so these two elements 3, 4, 4, 3. This can be swapped. Swap operation. The top two elements of the stack can be swapped. Then peek, return the top element of the on the stack, but does not remove it from the stack. It returns the top element on the stack, but it does not remove it from the stack. Okay. Rotate the topmost items that can be moved onto the stack in a rotating fashion. The stack has a fixed location in the memory, but the data element pushed in the stack, the pointer points to the current element. So these are the operations. What are the stack operations? Push, pop, swap, peek, and rotate. Swap, peek, and rotate. So these are the different operations of the stack operation. So the question is like, which data structure is used to perform the recursion? Okay, so you may get a question like, which data structure that is used to perform the recursion, So stack is used to perform the recursion data structure. Which one? The stack data structure is used to perform the recursion in the data structure. It's a last in first out property. The stack data structure last in first out the property, so that helps to remember its callers. It helps to remember its callers, and this caller helps to know the data which it returns the function. So the system stack is used for storing the return address of the function calls. System stack that is used for storing the return address. System stack that is used to storing the return address of the function calls. Okay, so stack is used for the recursion in a data structure, and because of its property last in first out, it helps to remember its caller. And system stack is used for storing the return address of the function calls. Can a stack be described as a pointer? Can a stack operation that can be described as a pointer? Yes, stack that can be described as a pointer. Stack can be the stack data structure that can be described as a pointer. The reason is that it has a head pointer The reason is that it has a head pointer which points to the top of the stack. The stack operations are performed by using the head pointer, hence the stack is described as a pointer. So stack is described as a pointer. Okay. Is it possible to insert the different type of elements in a stack? Is it possible to insert the different type of the elements in a stack, and how? Yes, it is possible to insert the different type of elements in the stack, and the elements in a stack can be inserted using the push operation. As you know, the stack is having the different operations: push, pop, okay, push, pop, peek, rotate, swap. These are the different operations of the stack. So elements in a stack that can be inserted using the push operation. The push operation that writes an element on the stack. Push operation that writes an element on the stack and moving the pointer. So there are different elements can be inserted into the stack. Different elements can be inserted into the stack, and this is possible by implementing the union or a structure data type. So there are different elements are inserted into the stack, and this is possible by implementing a union or the structure data type. Okay, and it is efficient to use the union rather than the structure, so only one item's memory is used at a time. So the question is that, is it possible to insert the different types of elements in a stack? Yes, it is possible to insert the element in a different type of elements in a stack, and the elements in a stack are inserted using the push operation. The elements that are inserted in the stack operations are using which operation? Push operation. That push operation, it writes the elements onto the stack and moving the pointer as it after inserting the elements, it moves the pointer. So after inserting this particular element, it moves the pointer here, moves the pointer. So there are different elements that can be inserted into the stack, and this is possible by implementing a union or the structure data types. So it is efficient to use the union rather than structure. Okay, next we'll discuss the queue operation. As you know, stack is a last in first out operation where the elements are pushed onto the stack, and the push operation that writes the element on the stack and moving the pointers. So there are different elements that can be inserted into the stack. So this is possible by implementing the union of structured data type, but it is efficient to use the union rather than structure. So let us discuss about the queue operation. Okay, so queue, as we know, the insertion at the front of that back end and deletion from the front end. The queue operations are push the insert the element in the queue at the end, insert the element in the queue at the end, and pop that removes the element out of the queue from the front. The return is also the one of the operation, the queue operation, that is it return the size of the queue. It returns the size of the queue. Push, pop, then size of the queue, then front, it returns the first element of the queue. Front is return the first, okay, for first element of the queue. So in this particular queue, okay, so this is queue where this is the back end, so this is the front end, so the insertions here, the insertions of the elements and the queue at the end here, the insertion will be taking place, and here this is NQ operation. This is NQ, and here it's a DQ. Here DEQU DQ operation. Okay. So push pop size, that return the size of the queue, front, that return the first element of the queue, and empty, it is to find the empty. Okay, if the means to find if the queue is empty. So what is DQ? DQ. A DQ is a double-ended queue. Double-ended queue. It is an abstract data type similar to the simple queue, and the elements here that can be inserted or the removed from the either end. So in the queue, the insertion and the deletion that can be removed from the either end. So it allows to insert and delete from the both the sides, means the items can be added or deleted from the front and rear end. So the queue, it is a sequence of data, and the data that can be added only at the front or at the end. The data can be added at the front or at the end, and the data can be removed only from the front or the end. The data can be examined only at the front and end. The data can be examined. So what are the difference between the stack and queue? Difference between the stack and queue. So the stack represents the collection of elements in the last in first out order. Last in first out order. What is that? Stack. Then queue, first in first out. It represents the collection of the elements, in the first in first out order. In the stack, the insertion and deletion or operations are performed at the same end, but in queue, the insertion and deletion of the elements are performed at the different end. Okay, stack where insertion deletion are performed at the same end. So that is the stack operation. Okay. Then in the stack, only one pointer is used in a stack, which is called as top of the stack. So in the only in this particular stack, the top of the only one pointer is used to stack, so that is called a top of the stack pointer. Here in queue, the two pointers are used, that is called as the front and rear. So there is in stack there is no wastage of the memory space, but in queue there is a wastage of the memory space. So let us discuss some example for the stack and queue. So this is the example for the stack operation, and this is for the example for the queue, right? Okay. So in this particular like stack operation, plate counter at the marriage function reception. So an element is inserted at the top of the stack and removed from the top as well, that is in the stack. So here the plates, here if an element is inserted at the top of the stack and it is removed from the top as well. So here these are the number of plates, right? These are the number of plates. So if these number of plates are inserted from the top of the stack and it is removed from the top as well, so it is a bounded capacity and stack operation, and that includes the testing the null stacks. So finding the top element in the stack, removal, and the topmost element, and adding the element on the top of the stack. So in queue, the students standing in a line at a free counter. So here there is a counter where the student in a line is standing at a free counter, means there is no like you should attend or like. So queue means it is a here the insertion and deletion from the different ends. An element is inserted at the end of the queue. The elements are inserted at the end of the queue and it is removed from the front. It is removed from the front. So here the in this case the elements are inserted at the one end of the queue. Elements are inserted at the one end of the queue and deletion from the another end. So that is called a dequeue operation. So it can be of bounded capacity, but is usually implemented without the specific capacity. Without specific capacity. So the queue operation that includes the testing a null queue, finding the next element, and removal of the elements and inserting the element from the queue. Okay, so that is about the difference between the stack and queue. So describe the following terms of a tree. What are the terms? Level of the tree, height and degree. Level, height and degree. So there are these terms. So let us take example to define the term. So here the levels, height and degree. So here we consider there is one diagram, binary tree, where this particular node it represents the root of the tree, and here the child nodes are B, C, M, E. So these are the root node. The level is called as level 0 and level 1, level 2 and level 3. Level 3. So here this particular node it is a parent node. It is a parent node and child nodes. Okay, and it is a subtree. This KAN it is called as subtree. Okay. So let us discuss the different levels. So the levels of any node is defined as the distance of that node from the root. So that is the level of node, distance of that node from the root, the distance of that particular node from the root. So that is called as levels. The level of a root node is always 0. Here the level of the root node is always 0. It is always 0. Then consider in the level 1 what are the different nodes? B, C, M, E. So here is there B, C, M, E. B, C, M, E are at the level 1. So this is level 1 and level 2. K, G, H, I, J. The nodes are in the level 2. A, N, O, P, Q, R. So that is level 3. Okay. So here the mentioned level 2, level 3. The height is also the level, means it is any node. It is defined level of any node is defined as the distance of that node from the root. The distance of that particular node from the root is called as level. The height is also known as the depth of the tree. The height of a tree. Okay, height is also known as the depth of the tree, and the height of root node is 1. So here in this case the height of this node is 1. Okay, so height of the node is 1. Height is also known as the depth of the tree, and it is the root node in is 1. The height of the root node is 1. So height of the tree is equal to 1 more than the largest level number of these. The height of the above tree is 4. So for this particular tree, the height is 4. The height is 4. So how we calculate? The height of the tree is equal to 1 more than the largest level. So how many levels are there? Levels in the tree. How many levels? There are 3 levels. Okay. So 1 more than the largest level of or largest level number of tree. So that is the height. So here how many levels are there? So this is 0, level 1, level 2, level 3. So height is 4, because here we are not added these levels. Okay, so level 1, the height means it is 1 more than the largest level of the number of the tree. One more than the largest level number of the tree. Level is over, then height is which discussed height, then degree. The number of children of a node is called its degree. The number of children of a node, the number of children of a node is called as degree, and the degree of node R is 4. First it will come the degree, then we'll analyze the height. Height means it is 1 more than the largest number of the tree. 1 more than the largest number of the tree. Okay. So then level is okay. Height, then degree. In degree means the number of children of a node. Number of children of a node is called its degree. The degree of node R is 4. The degree of the node 4, where it is, the degree of node 4, okay, Q operation. Okay, I think it is not available. Okay. So level height means it is 1 more than the largest level of the tree. Then degree, the number of children of a node is called its degree. So the degree of node 4, so the degree of node 4 and the degree of node B is 3. Node B is 3 and node R is 4. The degree of okay, so the diagram is not there over here. The degrees of 4. Okay, so the nodes, the levels are okay. Levels, there is 1 more than, that is height. Okay, then degree is the number of children of a node is called its degree. The degree of a node R is the node B, that is 3, where the degree of node S is 0. The degree of tree is the maximum degree of the node of a tree. The degree of a tree is the maximum degree of a node of tree. The trees of a diagram that gives trees 4. Describe the binary tree. Describe the binary tree and its property. Binary tree, it is a special data structure which is used for the main purpose, that is the data storage. Okay, binary tree, it is a special data structure that is used for the main purpose is for the data storage. So in binary tree, a node can have the maximum two children. A node that can have the maximum two children. So okay, the it is maximum having the two children, and we can say a mode can be have 0 or 1 or 2 children. So it has a special condition. This binary tree has a special condition that each node can have two children at a maximum. Okay. It has also benefit of both an ordered array and linked list, as a search is quick in a sorted array. So the insertion and deletion operations are fast in the linked list. Which one? Insertion and deletion operations. So the properties of binary tree is the maximum number of nodes in any level I is 2i. The maximum number of nodes that is possible in the binary tree of height is 2h minus 1. 2h minus 1. The minimum number of nodes that is possible in the binary tree of height h is equal to h. If a binary tree that contains the n nodes, then its maximum possible height is n. Minimum height possible is log n plus 1. Okay, log 2 n plus 1. Can you describe the full binary tree and the complete binary tree? So full binary tree, as the name indicates, full binary tree, it is the levels have the maximum number of nodes. Okay, it is a fully binary tree. The height of fully binary tree is 2 raised to h minus 1 nodes, where h is the height of the possible tree. So 2 raised to h minus 1 node. 2 raised to h minus 1 node. Next we'll discuss complete binary tree. So this is fully binary tree, where the height of the fully binary tree is measured by 2 raised to h minus 1 nodes, where h is the height of the tree. Height means it is one more than the level, so this is h is the height of the tree. And complete binary tree. So complete if all the levels have the maximum number of nodes except possibly that the last level, then it is a completely binary tree. So the maximum number of nodes in the complete binary tree is 2 raised to h minus 1. The maximum number of nodes that complete the binary, 2 raised to h minus 1 nodes. 2 raised to h minus 1, that is nodes. Okay, so this is about complete and fully binary tree. So this fully binary tree, where each node is having the children's, so that is fully binary tree. So then complete binary tree, where some of the nodes don't have the leaves. Okay, explain the extended binary tree. A binary tree can be converted into the extended binary tree that can be extended by using the extended binary tree by adding any special needs, special nodes to leaf nodes, and nodes that have only one child, so this is the binary tree, and it is extended binary tree. extended binary tree. So binary tree can be extended by extended memory by extended binary tree by adding the special nodes to the leaf nodes leaf nodes. So the extended binary tree is also called as a two tree. Extended binary tree, it is also called as two tree. In the above figure, the external nodes are shown by the external nodes. These are the external nodes shown by squares, and other internal nodes by the circles. So these circles. So the extended binary tree is a strictly binary tree, means each node has either 0 or 2 children. Extended binary tree is strictly a binary tree, that means each node is having the either 0 or 2 childrens. Okay, so the internal path length of binary tree is sum of the path length of the internal nodes. How does the threaded binary tree is represented in the data structure? Threaded binary tree. So this threaded binary tree that consists of the nodes that is in the binary tree and having no left or right child. So this particular the child comes. So this child comes in the end. It is also called a leaf node, and there is no present scenarios. Okay, it is represented by the null pointer. Okay, so this is a tree. Describe AVL tree, or the height of balanced binary tree. So AVL tree is a binary search tree where the difference in the height of left and right subtree at any node that can be at most 1. The difference in the height of left and right subtree of any node that can be at least at most 1. The difference is at most 1. Balancing the binary search tree was introduced by the Russian mathematicians RM GM Adelsons. The height of balanced this binary search tree is called as AVL tree in their honor. So it is a where the difference in the height of left and right subtree is 1. That any node can be at most 1. So this is the example of AVL tree where the node 20 is having the child node 15, 57. So for this for the leaf node the 12. So this is the 12, 40, 65, 98. So for this AVL tree, what we discussed, AVL tree means where the difference of the height of left and right subtree, that should be that height of left and that's at any node that can be at most 1. So for this leaf node 12, and 40. So these are the leaf nodes 12, 40 and 65 and 98. So these subtree are empty. These are the empties: 98, 65, 60, then 12. So these are the groups they are empty. Okay, for a leaf node with 12, 40, 65 left and right subtree are the empty, so that the difference of height of their subtree is 0. For node 20, so this one for node 20, the height of left subtree is 2. Yeah, this one and this one. The height of subtree is 2 and height of right subtree 3. This is 1, 2 and this is 3. Okay, so the difference is 1. In node 15, the height of left subtree except the left subtree is 1 and height of the right subtree is 0, so the difference is 1. Okay, similar to for other nodes. So the here in AVL tree the difference in the height of the left and right should be 1. So you want to insert a new item. If you want to insert a new item in the binary search tree, how would you do? So let us assume that you will insert a unique element in the binary search. So the first of all, check if there is a limit. Okay, there is a memory limit. First of all, check if there is any tree, if the tree is empty, and if it is empty, then you can insert the new item in the root code. If it is empty, okay, if it is empty, then you can insert a new items into the root node. If it is not empty, then refer a new items key. Okay. Okay. So the recursive algorithm is a method of simplification that divides the problem into subproblems. Recursive algorithm is a method of simplification. The result of one recursion is the input to the next one. So that is the recursive operation. The result of one recursion is next to the next in recursion. So the repletion is in the self-similar fashion, and the algorithm that calls itself with the smaller input values and obtaining the result by simply performing the operation. So these are the following terms that base case, base case, recursive case, runtime stack, and tail recursion. Okay, so base case means a case in recursion in which the answer is known with the termination recursive. So a linked list is a linear arrangement of the data. So here in the linked list, it is a linear management of the data. Linear management here. So linked list, it is a dynamic data structure. Linked list is a dynamic data structure. Linked list is a dynamic data structure, and it consists of sequence of data elements and references to the next record sequence. What are the types of linked list? Are singly linked list, doubly, and circular linked list. So in a singly linked list, it has only the head part and corresponding reference to the next phase. Corresponding reference to the means the list that contain its own value, and also it contain the address of the next element. Okay, so here in this way, singly linked list, doubly linked list, the linked list which has both the head and tail parts, so that allowing the traversal in any bidirectional fashion. So except the first node and the head node that refers to previous node. So in the circular linked list, a linked list whose okay, in doubly linked list which has both the head and tail parts, allowing the traversal in bidirectional fashion. Except the first node, the head node refers to the previous node. In doubly linked list, in which it has both the head and tail parts. Doubly linked list, head and tail parts, thus allowing the traversal in a bidirectional fashion. So circular linked list, a linked list whose the last node has a reference to the first node. The A linked list whose last node as a reference to the first node. So that is linked list. Okay, means here the reference, here the last node has a reference to the first one. So this has a reference to the first one. That is circular linked list. Describe the steps and how to insert the data into the singly linked list. So insert the data into singly linked list. Insert in the middle. First step is insert in the middle. So the data is already the 1 2 3 5 1 2 3 5 where the data singly linked list. So locate the node after which a new node says 4. A new node says 4 that needs to be inserted. Create the new node that is 4. Point to the new node, so that is 4 to 5. Next point to the node 3 of node 4. Okay, so this is about the singly linked list. So next comes the space complexity and the time complexity. So space complexity, as the name indicates, it defines the storage capacity of the input data. Storage capacity, okay, storage capacity of the input data, and it defines the amount of memory. It defines the amount of memory that is required to run the program to completion. So that is just we have provided the power. So the storage complexity that defines the capacity in which storage capacity in which okay, space complexity means it is depend upon the size of the input data and the function that is used. The function that is used for the input size n. The time storage, so that is about the storage capacity of the input data, and so time complexity is deals with the amount of time required by the program to complete the whole process of execution. Time complexity, the time complexity that deals with the amount of time is required to a program that that whole process the execution. Time complexity can be made such that a program can be optimized on the basis of the chosen method. Linear search is simplest form of search. It searches for the element sequentially starting from the first element. So this search has disadvantage if the element is located at the end. So advantage lies in the simplicity of the search. So these are some of the important things about linear search, and it is most useful when the elements are arranged in the random order. So let us discuss what is bubble sort and quick sort. Bubble sort simple sorting algorithm. It involves the sorting list in repetitive fashion. Okay, so these are the different features characteristics of the bubble sort. Quick sort is the best sorting algorithm which implements divide and conquer concept. So in the quick sort, it uses the divide and conquer method, and it divides the elements into two parts by picking an element. Okay, it arranges the element whose whose they are smaller than the pivot. So merge sort algorithm, that is comparison based on the sort algorithm. So merge sort algorithm steps are as follows. So you have to make your label as heading, and in the topic, just a step here you have to mention the steps you have to mention. Define linear non-linear data structure. Linked list is example of linear data structure or storage. Linked list stores data in a organized linear fashion, and they store the data in the form of lists, and it traverses the data element sequentially, in which only one one data element that can be directly reached. So linear means here the linear data storage or structure where the data are organized in a linear fashion. The data is organized in a linear fashion. Okay, so this is about the non-linear. Non-linear means the tree data structure is an tree graph. These are all non-linear data structure. A tree has one node called root node, and that is starting point of the that holds the data. Okay, non-linear data structure. A tree has one node called as a root node, that is starting point and holds the data. Non-linear structure.